Hello everyone, so hopefully my voice is audible, and I'm not expecting this like mic is super good and this will be noise free, but yeah, this will be my first live stream that I'll be putting live on YouTube. So yeah, so today I'm going to learn about mutex, how to use it. So basically mutex is a feature in the multi-threading which helps us to share variable between different threads. So basically we can share variable across various threads which are running concurrently, not exactly concurrently, but the but like it the illusion that FreeRTOS creates basically. So that's it. So basically I don't know much about it, and I wanted to learn it from a long time, because like for each task, like I see, yeah, so I wanted to learn it from a long time. So yeah, so let's get started. So let's ask first chat GPT, what is mutex? What is a mutex? Mutex in case of RTOS. Let's also start the documentation of FreeRTOS, RTOS, mutex, semaphore, and mutex. Yeah, so basically today my task is to share variables between two threads, and basically I don't have any electronics sensors or anything to check. I just have one ESP32, so we'll try to learn it without using any additional components. Yeah, so let's see what ChatGPT says. What is a mutex in case of RTOS? Let's see. In context of a real-time operating system, a mutex, or short mutual exclusion, is a synchronization object that controls access to shared resources. Like I said, it is used to prevent multiple tasks from accessing the same resources simultaneously, which can lead to race conditions and other types of unpredicted behavior. Yeah, so basically suppose a task is accessing one variable, and at the same time another task is changing that variable. So there can be a condition which is unpredictable, because at the same time one thread is trying to make changes on that variable and another thread want to access that variable, so that can lead to unpredicted behavior. So yeah, so basically to control that we use mutex. Oh, this is so tiring, like to speak and learn. A mutex has two states, logged and unlocked. Let me check if my face is visible in the video. Yeah, I think this is the correct frame. Yeah, let's start. A mutex has two states, logged and unlocked. When a mutex is logged, it prevents other tasks from accessing the shared resources. When it is unlocked, other tasks are available to access the resources. When a task attempts to lock a mutex that is already locked by another task, the task will be blocked until the mutex becomes available. Okay, so yeah, so let's try to process this. When it is a mutex has two states. Okay, so basically there are two states of mutex, one is locked and one is unlocked. Yeah, so I think these two states are used to give access or hide access from a thread. Yeah, got it. When a mutex is locked, it prevents other tasks from accessing the shared resources. Okay, so if a mutex is locked, so basically when a particular variable is in operation, the mutex is locked, so another task cannot access it. Yeah, got it. When it is unlocked, other tasks are able to access the resources. Okay, so basically when it is unlocked, other task is able to access the resources, basically like a room is locked, so we cannot access it, and if it is unlocked, we can access it. When the task attempts to lock a mutex that is already locked. Okay, so basically if a room is already locked and we try to lock it by other tasks, then the task will be blocked until the mutex becomes available. Okay, then the entire task will be blocked. Okay, when a task attempts to lock a mutex, so basically if a task, okay, if a mutex is already locked and if a task tries to lock it again, when the task, okay, then that task that is trying to lock the already locked mutex will be blocked until the mutex becomes available. Okay, so the mutex will say, oh wait, I'm already locked, so just block for a second, and when a mutex is unlocked, that state will be available. Got it. Mutexes, oh, this is tiring. Mutexes are commonly used in RTOS to protect shared data structures, hardware registers, and other resources that may be accessible by multiple tasks. They are essential tool for ensuring the correct and consistent operation of RTOS in multitasking environment. Okay. Okay, so yeah, we got it. What is a mutex? And let's see if we can get. I don't know what is the difference between semaphore and mutex. So we will just limit our learning to mutex only. I want to learn from YouTube videos rather than watching documentation, so my first preference is go to some video who has already taught how to do who has already used his or her time to explain how it works. And if I am unable to get such video, then I go to documentation. Yeah, so actually that is quite bad, but yeah, that's how I learn. Mutex is purely mutex example. No, there is a good channel called controller something. There was a good video on it. I forgot. Yeah, this is the channel. Control the controller. Okay. CONTROR. He has made a video on semaphore. Let's see the playlist. I think both mutexes and semaphore are the same. So if we are unable to get mutex, so we'll learn how to use semaphore. FreeRTOS task are Q1, Q2, semaphore. Yeah, so basically he has made a video on semaphore. So yeah, let's learn semaphore. We'll check out mutex later and what's the difference. I think both are used for the same purpose. There are a slight difference between both. If anyone is watching this live stream, so let me know in the comments if at all. Oh yeah, it is gone. Semaphore. Let's block the audio for this because
hello everyone.
I want I want you all to go and learn from this video.
So what I did here is made an interrupt button ISR handle, and if a button is pressed, so it will give the access to the semaphore. Okay, I'll have to process this again. हाँ हाँ एक मिनट आया. हाँ बोलिए.
हो गया
वो
Okay. So yeah, so basically in this tutorial he talked about how to basically the logs that we were talking in mutex also is applicable here. So basically he has two tasks running, task 1 and task 2, and he has defined a semaphore handle here which is x semaphore, and in task 1 he is giving the access to semaphore, and once the task 2 gets the access, it prints this message, got message. So yeah, so this is how it works, and I think after it gives the access, does it block it again? I don't know man, let's see. Yeah, so basically he's explaining how to use interrupt. So just try to implement the stuff that he has taught up till now, and let's see. So basically I don't want to write all the code from scratch, so let's copy and paste the code and play with it. FreeRTOS semaphore main make list.txt main.c. Yeah, so this is the, I'll just copy it and we'll use VS Code file, new project, control P, new project, esp-id of project. So basically I installed esp-id of in VS Code itself because I really like this I really like VS Code. You can also use the official ID by espressif, but yeah, but I like VS Code, so I installed this SEMAPHORE. I hope the spelling is right. Semaphore test. Let's choose a directory. We'll use it in espressif. esp-idf. Let's add it in examples. Let's add it here. Select folder. And let's choose, I don't know like how this affects the building process, but let's select the chip config. No components required. Choose template. We'll just choose the basic get started the sample project. Yeah, that is enough, I think. Create project using sample project. Yes, open it in the window. Let's open main file, main.c. कोडिंग दरवाजा बंद कर. I think I'll have to keep the session very short today. We'll try to like set for an entire day from next weekend. So I'll just play with okay, I don't want to use ISR and everything. I just want to use the stuff that he has taught in the first video. So yeah, this is the task 1 handle, this is semaphore, this is I don't want to use this. I did here everything. I don't want this ISR handler. This is task 1, this is task 2. I don't want this waiting for the button. Hello from task 1. Just check out the code he has written on the demo and just try to replicate that only. Yeah, printf send message, task 1 while 1, printf send message, x semaphore give v task delay. Okay, printf hello from task 1, so v task delay, let is added in the end, but I don't think that will make any difference. Let's check out what's in the task 2, v task delay. Then waiting for the button, I don't need that for now. X semaphore take and just print the message. X semaphore take, port max delay, printf got message. In the app main, I'll just have to create. Let's check out what he has written in the app main. He just created the X semaphore, initialize the semaphore, and then just activated the pin to core. Okay, he has pinned the task 2 to core 1. Okay, I think that is, these I think are unnecessary right now. Okay, so basically we have one semaphore handle here, and what the task 1 does is it prints hello from task 1 and give the access to the semaphore. Let's check out the definition of this. X semaphore, define X semaphore, being expressif. Let's ask ChatGPT. What does example give to in FreeRTOS? How to use it? Okay, let's give it time to figure out the answer, and by the time it does that, let's compile our code. Compile and flash our code. Let's see. Yeah. Semaphore give is a function in FreeRTOS API that is used to give or release a semaphore. Semaphore is a synchronization object that is similar to mutex, but it can be used to control access to shared resources by more than two tasks. Okay, so the difference between semaphore and mutex is that it allows us to give used to control the access of shared variables amongst tasks which are greater than 2, and mutex just allow to do that if only for just 2 tasks. Okay, to use semaphore you will have to need to create a semaphore using semaphore create binary. So this thing we are doing in the main function, I think. Yeah, or semaphore create counting function. Okay, once you have semaphore you can use semaphore, you have to release it. Okay, here is an example to use semaphore given FreeRTOS semaphore release it. Okay, in this example semaphore give function we used to release a semaphore allowing other tasks to access the shared resources. It is important that the semaphore give should only be called when the calling task has acquired the semaphore. Okay, this should be not. Okay, if the semaphore is not currently held by calling task, semaphore give will return an error. Okay, how to lock the access. Let's see. Oh shit, man, I'll have to ask it again, I think. I hope it stores the chat history. Let's see. Yeah, this it has stored the chat history. Yeah, how to lock it. Let's see. To lock a semaphore in FreeRTOS using a semaphore take function. This function will block the calling task until the semaphore becomes available, and then it will acquire the semaphore for the task. Okay, semaphore take blocks it. So our project is building here, as you can see. So basically task 1 gives the access to semaphore, and task 2 blocks the access. What does it return? What does semaphore take returns? Okay, I don't know how this is working. There is still this confusion. To lock a semaphore FreeRTOS, you can use semaphore take function. This function will lock the calling task until the semaphore becomes available, and then it will acquire the semaphore for the task. Here's an example of how to use semaphore take to lock a semaphore. In this example, the semaphore take function is used to acquire the my semaphore. Okay, is used to acquire the the port mice delay parameter specifies that the task should block indefinitely until the semaphore becomes available. Okay, it is important to note that when the task has acquired a semaphore, it should call a semaphore give to release the semaphore when it is finished using the shared resources. This would allow other tasks to access the resources. Okay. So I think what's happening here is this is releasing the semaphore and this is blocking the semaphore. So If it's blocking, I think it will return 1. If it is blocked, then this will print this, then it will go into here and this will unlock the semaphore. Yeah, I think this is how it's working. Flash done. So what does it return? What does X semaphore take returns? What does water X semaphore take? All are returns. Oh my god. And there are still few bugs with ChatGPT. I think they'll fix it as soon as possible. The semaphore take function in the FreeRTOS API returns a value indicating the success or the failure of the operation. If the semaphore is successfully acquired, X semaphore take will return okay, true, okay. So this function is trying to acquire the access to the semaphore, and if it is true, this it prints the message, and this give what is okay. Basically, this locks it and this unlocks it. Hello from task 1. Why don't we see hello from? Okay, got message. Okay, things are not clear to me. What is not clear? So basically, what this function is giving, I don't know. What if we don't use this? Then let's see what happens. So let's try we'll have to close this. Basically, I am not understanding what this function is giving, because here this function is trying to access the semaphore, but before accessing, I think before accessing the variable the semaphore, some other task should give the access of it, but the task 1 is not accessing semaphore at the first place. Then how it's giving the access, like why it is necessary to give the access to another task? I'm having difficulty understanding that. Hello from task 1. Hello from task 1. Okay, so we cannot see any messages being printed. Basically, the task 2 get blocks, like don't proceed after this if statement. Okay, so how is it accessing the mutex? Where it is accessing the mutex? I'm not understanding. Basically, my question is, this variable is not, this task is not accessing mutex in the first place. I think, okay, let's try to
basically what if we write this, in the main function, and let's see what happens. So basically the access to the semaphore will be given in the main function itself, and after that let's see if we are able to get caught messages. I'm still not clear like how it's working, but yeah, let's see. Sorry for the audio quality, it's quite bad, I know, but I just wanted to get started with live streaming because I wanted to do this for a long time, but I was procrastinating for some reasons. Okay, so we are now getting both. We have got message for one time because we have got the access to the semaphore here, and after that we were able to get once from here, but somehow we lost the access when the task 1 ran for one time. So I don't know who is blocking the access then. Okay, let's ask ChatGPT. Do we need to use semaphore give before using semaphore take every time? If yes, why? It is generally recommended to call semaphore give to release the semaphore before calling semaphore take to acquire it again. This is because semaphore take will block the calling task. Possible. Okay. By releasing the semaphore before trying to acquire it again, you can ensure that the semaphore is available when the task needs it and the task will not be blocked. Okay. This can help to improve the performance and responsiveness of the system. Here's an example of semaphore loop. Okay. Semaphore and my semaphore create the semaphore while one semaphore give semaphore semaphore take release the semaphore acquire the variable access the shared resources here. Okay, in this example the task releases the semaphore with semaphore before trying to acquire it again. The semaphore take this ensure the semaphore is always available when the task needs it and task will not block it. This is important to note that the semaphore must be initialized before it can be used. In this example, the semaphore is created to the semaphore. Actually, it is also important to call semaphore only when the calling task has already acquired the semaphore. If the semaphore is not created, then okay. So what happens? Basically, it's saying that before taking the variable, we have to give the access to the semaphore. But my question is, why to give the access if the task does not have the access to it? So what happens if we
what happens if we use X semaphore give before X semaphore. So basically, from the last example, we saw that it just printed got message for one time, and after that the semaphore was blocked and we just saw hello from task 1. So I think what should happen here is we are what's happening here is we are giving access to the semaphore and then we are taking the semaphore. So we should see got message and hello from task 1 both here if we build this. So let's stop this first and let's try building a monitor. I think we should now see both hello from task 1 and got message. Let's see. Yeah, like I said, like I said, we are able to see both got message and hello from task 1, but I don't know why we are saying got message 2 times and hello from task 1 for 1 time. I think that is because of the delay used. So we got to learn that we have to use X semaphore give before accessing the X semaphore take, but still I don't know like how to use this in the real use cases. So I think I'll do another live stream for that in the future. For now, I think that's enough. Bye. If anyone has watched the videos, do comment down in the comment section like any feedbacks, improvements, or do you like want me to continue this, and any topics in embedded system that you want me to learn. Yeah, bye. I'm stopping this.